All right, chapter 6, section 1, perpendicular and angle bisectors. Yes, we already know what these words are, but now we're going over the theorems and how to use them. So yes, we are still working with proofs. Perpendicular means what? So can anybody tell me? Yes. You're going to show me?
Yeah.
Okay, good. We can't see it on the recording, but what she's doing is making a little cross with her hands. So it does make it intersects at a 90-degree angle. Okay, so all those angles are right angles. Yes, that's what perpendicular means. And angle bisectors. Can someone tell me what that means? Angle bisectors. So we should know what an angle is, and we should know what the word bisector or bisect means. Bisecting an angle, what does that mean? Going through an angle, making it congruent, right? Cutting an angle in half equally. Okay, good. At least we know those vocabulary words. All right, so perpendicular bisector, by definition, this is what it means. Okay, again, this is something that we have seen. A segment ray line or plane that is perpendicular, so this right here is perpendicular to a segment at its midpoint. That's a mouthful. You can only bisect a segment. However, a line, ray, plane, or segment can cut it in half, okay? Again, only a segment can be cut in half because it has two endpoints. So when it's cutting in half, it means it's making these two segments congruent. This is the same length as this segment right here. So if I'm looking at this and I were to write it as a statement, it would be written as CP is the perpendicular bisector of AB. This is how it'll be written as a statement, okay? So we will consider this line CP is the perpendicular bisector of AB. It is what's bisecting my segment. Equidistant, we should know what that means. Equal in distance. All right, we have seen equiangular, equilateral. Okay, now we have equidistant, equal in distance. So that should be super easy for us to know. All right, perpendicular bisector theorem. Okay, this is now the theorem. So I'm just going to underline it so we know it's the theorem. And what this says is in a plane, if a point lies on the perpendicular bisector of a segment, then the point is equidistant from the endpoints of the segment. I know that's a lot, so I'm going to highlight. It says, if a point lies on the perpendicular bisector of a segment, so this is my point that lies on my perpendicular bisector. My perpendicular bisector is right here. Okay, here is my point also along my segment. It's saying then the point is equidistant from the endpoints, meaning if I were to draw a line, which they did, this is the equal distance from my segment. So looking at this statement, if CP, so I'm gonna highlight stuff. CP, if line CP is the bisector of AB, so here is my bisector. Ooh, not right there. The bisector of AB. Okay, that's my bisector. I know it's bisecting because of my 90-degree angle. Then it's telling me CA is equal to CB. Okay. So this is perpendicular bisector theorem. This means I'm going from a perpendicular bisector to showing that my segments are equal distance, two equal distance segments. Equidistant segments. Okay, why am I writing that? Because of the next one. Okay, this is perpendicular bisector theorem. Now I'm going to look at the converse of perpendicular bisector theorem. So now I'm doing the opposite, okay? So before I went from the perpendicular bisector to a segment, now I'm going from equidistant segment to my perpendicular bisector. So I'm just doing the opposite. Okay? So reading this one, it says in a plane, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So I'm doing the opposite again. So looking at what they're giving me, they're saying if DA is, again, congruent, equal distance, then point D, here's point D, lies on the perpendicular bisector of AB. Okay, so this one I'm going from an equal distance segment to a perpendicular bisector. This is converse. The perpendicular bisector theorem by itself was from a perpendicular bisector to then equal distance segment. So understand the opposite. Another way that this could be written, okay, so make sure you're writing this so you have it. It says if DA equals DB, I could also write it as, then C lies on the perpendicular bisector of AB. I could write it that way. Okay, I could write it looking at C. So this would be drawn as, let me go ahead and get a different color. It could go this way. I could also write it as P lies on the perpendicular bisector of AB, which it does. Okay, they kind of already showed us those congruent marks. That's the ones in red that they have right here. Or I could also write CP is the perpendicular bisector of AB. Okay, so pay attention to the last one because it is the perpendicular bisector of AB. All right, looking at example 1, it says BD is the perpendicular bisector of AC. So when I'm looking at this one, they are telling me my perpendicular bisector. I have to find my segments. So is this perpendicular bisector theorem or perpendicular bisector theorem converse? Which one is this? So they're telling me it's a perpendicular bisector. I have to find my segments. So this one is going to be perpendicular bisector theorem. Okay, this one is not converse because remember, converse is telling me that my segments are congruent. Are they telling me my segments are congruent here? No. They're telling me that I do have a perpendicular bisector. Now I have to find, will my segments be congruent? Yes. So now I can go ahead and solve. These will be congruent. So how would I solve this? Michaela?
3x plus 14 equals 5x.
Good. Yes, I am just going to go ahead and set them equal to each other and then solve. So I have right now 3x plus 14 equals 5x. Keep in mind they're not asking for x. They're asking for AD. So x is going to equal 7. I'm not done. They're asking me to find AD. So I have to go ahead and plug it in. 5 times 7, 35 is going to equal AD. And that's my answer. All right, looking at example 2, it says use the diagram and given information to find the indicated measure. So, looking at what they're giving me, I'm going to do it in different colors because there are 3 questions. It says XZ or ZX, line ZX, is the perpendicular bisector of WY. And YZ is 13.75. Find WZ. So they're giving me this side, which is 13.75. Am I using the perpendicular bisector theorem or the converse of perpendicular bisector theorem? Which one am I using for this? Is it converse or is it perpendicular bisector? Yeah. Good. So they're giving me my perpendicular bisector. They want me to find my equidistant segments. So this one I'm just going to go ahead and write. I am using the perpendicular bisector. Oops, a little too many E's. So this is what I'm using. So what is that telling me about my segments? Are they going to be congruent or no? Yes. So what should WZ equal? Good. So WZ equals 13.75. That one was pretty easy. Looking at the next one, it says ZX is the perpendicular bisector of WY. WZ is 4x minus 13, and YZ is n plus 17. They want me to find YZ. Which one am I using for this? Am I using perpendicular bisector theorem or the converse? Good, I'm still using that perpendicular bisector theorem. All right, now how would I find them? How would I find YZ? What do I have to do first? Yeah. Make them equal to each other, so I'm going to technically solve for n first. I'm going to do it up here. I have 4x minus 13 equals n plus 17. So going ahead and solving for n. Oops, I put x. It should be n, not x. This should be an n. Why is this not erasing? N. Add 13 to both sides of my equal sign. 3n equals 30. N equals 10. Okay, now I have to plug it in. Remember, I'm finding YZ. I'm not solving for n. So I'm going to go ahead and plug in 10 plus 17. That's going to give me 27 as my answer. So YZ equals 27. All right, now, and looking at the last one, it says find WX when labeling information. When WZ is 20.5, WY is 14.8, and YZ is 20.5. They want me to find WX. Is this perpendicular bisector theorem or the converse of perpendicular bisector theorem? Good, it's converse. So they're telling me that my segments are congruent. Converse perpendicular bisector theorem. They're telling me that my segments are congruent, and they want me to determine if my if it's a perpendicular bisector. So how would I solve this? What do I have to do? Good, you're going to divide this by 2. Remember, perpendicular bisector means you're cutting in half. So they want me to find the measure of only half of it. So 14.8 equals twice WX, so dividing both sides by 2. WX is going to equal, if you divide it correctly, 7.4. Questions on these examples right here? All right. Angle bisector theorem. So we did perpendicular bisector. Now we're doing angle bisector, meaning we're cutting the angle in half. Same thing, we're also going to have a converse for this one, but understand what angle bisector theorem is. If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So looking at this, if a point, let's say this is my point, is on the bisector of an angle, then it is equidistant from the two sides of the angle. Okay, so looking at the statement, this says if ray AD, okay, so this is my ray, bisects BAC, so that's my bisecting right there, and DB is perpendicular to AB, perpendicular is right here, and DC is perpendicular to AC, then I know that my segments are going to be congruent. So these are my segments that I'm looking at. I'm proving that these are congruent right here. So angle bisector is going from my angle bisector to equal distance segments. Okay, keep in mind, in order for you to tell that your segments are congruent, they must be perpendicular. Okay, so you have to look for your right angles. Okay, you have to have those right angles. Keep in mind, looking here, they're giving you those perpendicular symbols. They must be perpendicular. So this is angle bisector theorem. Okay, you're going from your angle bisector to equal distance segments. And then we also have converse, which is the opposite now. So instead of going from angle bisect to equal distance segments, I'm now going from equal distance segments to proving that it is an angle bisector. So this is my converse. I'm going to go ahead and write it. I'm going from equal distance segments, equidistant segments, to angle bisector. Okay, so reading this one, if a point is in the interior of an angle and is equidistant from the sides of an angle, then it lies on the bisector of the angle. Okay, so highlighting again, if I am given those perpendicular symbols, which are right here, and they're telling me that my lines are congruent, then I know that this ray bisects my angle. Okay, so I'm doing the opposite. Instead of going from my angle bisector to equal distance segments, I'm going from equal distance segments to angle bisector. Okay, so you have to remember which one's converse, which one is not converse. So going ahead and looking at the examples. Looking at example A. Okay, for example A, what are they telling me that is congruent? What is congruent here? Looking at it, what is congruent? Is it my segments or my angles? They're giving me my angles. So is this angle bisector theorem or the converse of angle bisector theorem? Good, this is going to be angle bisector theorem. Okay, they're giving me my angles. So this is going to be angle bisector theorem. And because my angles are congruent, what do I know about my two segments? They're going to be equidistant. So x is going to equal 15 as well. That one was a pretty easy one. All right, looking at B. What are they telling me is congruent? Are they giving me my angles are congruent or my segments are congruent? My segments, they're showing me using those segment symbols, which are right here. So is this angle bisector theorem or converse of angle bisector theorem? Good. This is going to be converse of angle bisector theorem. All right, so because my segments are congruent, they're perpendicular and congruent, what do I know about that ray? Okay, what do I know about this ray right here? It's going to cut my angles in half, right? So these angles are now going to become congruent. These angles are congruent, so how am I solving for x? Good, I'm just going to go ahead and set them equal to each other. So I have 3x plus 5 equals 4x minus 8. And I'm solving for x because that's what they're asking for. 5 equals x minus, is it 8 or 6? I think it's 6 as well. Let me change this. So this should be 6. Okay, add 6 to both sides. X is going to equal 11. Good. Okay, questions on B? All right, let's go ahead and go to C. Which one's this? Angle bisector or converse of angle bisector? Good. They're giving me that, they're telling me my angles are congruent, so this one's just going to be angle bisector theorem. And then that means my segments are going to be equal distance, so they're going to be congruent. So again, how am I solving for x? Set them equal to each other. 5x equals 6x minus 5. Subtract 6x from both sides. To get x by itself, I'm going to get negative x equals negative 5. Divide by negative 1 to get rid of that negative symbol. X equals 5, which is positive. Questions on A, B, or C? Okay. All right, looking at this one, example number 4, I know on your graph, like I said, it's given to you, but I want to do the process with you so you know how to solve this. It says write the equation of the perpendicular bisector. Okay, that's super important that we know they're asking for the perpendicular bisector of this segment with the endpoints P and Q. So this is a process, okay? We have seen these before when we were doing perpendicular and parallel slopes using, and we were graphing them. So we're kind of doing the same process, so you have to please follow along because this is quite a long process. So looking at the first one, or the question, the first step is to graph. So step 1 is to graph P and Q. So yes, it is graphed for you, but I'm just going to do the process. Here is my P. Here is my Q. We're finding the perpendicular bisector, so that means I'm cutting my segment in half. So these are my endpoints, which means this is my segment. So I drew them, I connected them. Second thing, when you're cutting something in half, you need to find the midpoint. So I am going to go ahead next, find the midpoint. Of P and Q. Okay, so I'm finding the midpoint of my segment. Do you remember the midpoint formula? Sometimes you could just look at it and find the middle point, but sometimes it's not always going to work. So do you remember the formula? Yeah. That's the slope formula. So midpoint, think of it as you're dividing it by 2.
Isn't it x?
Isn't it
It's
x2
well, x2, yeah.
x1?
So it's going to be x1 plus x2. You're adding the 2 points and dividing it by 2. You're trying to find the middle. That's how you're finding the middle of something. Okay, and then you're going to have y1 plus y2 over 2. Okay, that's the midpoint formula. And now I'm just going to go ahead and plug in using the 2 points that they gave me. So if you're plugging in, you're going to get negative 2 plus 4 over 2. And you're going to get 3 plus 1 over 2. Okay, so solving it, negative 2 plus 4 is going to give you 2 over 2, which is going to give you 1 as a whole. And then 3 plus 1 is going to give you 4 over 2, which is 2 as a whole if you simplified. So right now I found my midpoint. I'm going to go ahead and put a dot on my midpoint, which is right here. So my midpoint is 1, 2. Okay, I'm going to highlight. This is my midpoint. So after I find the midpoint, dealing with the perpendicular bisector, I have to have my slope. So my second, or not my second because we just did our second, my third step is going to be find the slope of PQ. Okay, now, I think you guys were getting these mixed up. What's the slope formula?
y1 minus y2.
y2 minus y1.
y2 minus y1 over x2 minus y.
Good. Okay, that's my slope formula. So I'm going to go ahead and plug it in and solve it. Or you could count. Okay, you guys should know slope is rise over run if you didn't know. Rise over run. You could tell that your slope is going down, so you know it's going to be some sort of negative slope. So always look at it and determine what are you given. Can you kind of look at what they're giving you? So I'm going to go ahead and plug in what I have. I'm going to plug in 1 minus 3 over 4 minus negative 2. I'm going to change this to a plus symbol. 1 minus 3 is going to give me negative 2. 4 plus 2 is going to give me 6. Simplifying it, my slope is going to be negative 1 over 3. If I counted, okay, I'm not going up. I'm not rising. I'm going to go down because it's negative. 1, 2. I went down 2 over 1, 2, 3, 4, 5, 6, which is what I had. I just simplified it. So yes, you can count. That is fine. What do we know about a slope if it's perpendicular? Yes. Good. So because they're asking for something that's perpendicular, I'm going to use the perpendicular slope. So perpendicular slope. Perpendicular slope. I need opposite reciprocal. Okay, I'm going to shorten it. Opposite and reciprocal. So it's the opposite and reciprocal of negative 1 over 3. 3. So my slope for my new equation is going to be 3x. Okay, because we are using slope-intercept form. If you forgot slope-intercept form, it's y equals mx plus b. M being your slope. B being your y-intercept. All right, so I kind of have a lot of information here. Now I have to figure out what is my y-intercept. So hopefully you remember how to solve that. So for 4, this will be my last step. I'm going to go ahead and write my equation. However, I have to solve for b. So I'll write it as solve for b. Okay, how am I doing that? I'm using the perpendicular slope and the point it passes through. So I'm using the slope and point that passes through. Okay, which is 1 and 2. Because remember, it has to go through that point. It has to cut my segment in half. So how am I solving this? I'm using the y equals mx plus b. And I'm using my new slope. So I have y equals 3x plus b, but I'm using the point 1, 2. So plugging in what I have. I'm plugging in 2 equals 3 times 1 plus b. I'm trying to solve for that b. 3 times 1 is 3. So I'm going to go ahead and subtract 3 from both sides. And b is going to equal a negative 1. So that is my y-intercept. So my equation is going to be y equals 3x minus 1, and I'm going to go ahead and graph it. I'm going to go ahead and put a dot on my negative 1. And my slope should be up 3 over 1, which ends up to be right there on my orange dot. Up 3, 1, 2, 3 over 1, which ends up right here. And I'll just go down 1, 2, 3, down 3 over 1. So we kind of have a straight line. So if I graphed it as straight as possible, this is what it should look like, where my equation is y equals 3x minus 1. Some students asked, can't you just use your slope from this point? Yeah, that's fine. If you didn't want to have to do all of this, it's still the same thing. 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. You just have to be able to write it as an equation. And don't forget, your b is just where it goes through on your y-axis. Okay, questions on this? Will you have to do this work for this? Yes, on your homework assignment. So make sure you guys understand how to solve this. Questions, comments, concerns? All right, big idea homework. The description is on Canvas. Let me find it so I can tell you which questions you need to show work for. You need to show work for, I think there's 6 questions. You need to show work for, I think, 2, 4, 6, and 11, and 12, I believe. Let me double check. Okay, you have to show work for 2, 6, 9, 11, and 12. Okay, those are the questions you have to show work for. Homework is due tomorrow morning.